Alright, so this will be my second video in my complex analysis playlist, and I'm going to be talking about addition and subtraction of complex numbers in this video. So basically, complex numbers can be broken down. You can write them as z, they're typically written as z, but anytime you see z, you can always write that as x plus iy, and that's a very important relationship to understand early on, because a lot of problems that we do later on make heavy use of this property. It's a very important property. And likewise, z bar, which means the complex conjugate, is equal to x minus iy. And these two are incredibly important, but also you also have to know that the real part, this re simply means the real part of the complex number. So you write re parentheses z, just means the real part of the complex number, and that you can just get by z plus z bar over 2, and that's equal to x, and I'll show that in a minute. And then you have the imaginary part, which you write as imz, is equal to z minus z bar over 2I. Now, this is how that works. So basically, z you can always write as x. I'll write that a little bit bigger. I write that as x plus iy, and then you just add the conjugate to that, which I said was x minus iy, and you have that over 2, and so you're going to get 2x, and the iys cancel out, so you're not really left with anything. So you get 2x over 2, which is just equal to x. So that's equal to, so as you can see, the real part of a complex number is just the x, which is, what we expect, because the imaginary part is where the y is. Now, likewise, the imaginary part of z is just the y, and similarly, this is how we can find that out. So we have x plus iy minus x minus iy, from this is the conjugate, so I take it from here, and so the x's this time cancel. So, and I have iy minus a negative iy, which becomes 2iy. So we'll have 2iy over 2I, and as you know, the 2i's cancel, so you're just left with y. So that's this important formula to recognize. So basically, you can see that a lot of times in complex analysis, this is just a very simple example. I'm going to be showing all kinds of proofs, and they're kind of similar, and they're very similar to this, where we just kind of say, okay, z is equal to this, and we say it's equal to some, we try to show a property by saying x plus iy is equal to what we're trying to prove. It's kind of hard to say what the proofs are going to be like without actually taking a look at them, because complex analysis is very unlike anything else, but that's kind of beside the point. So anyways, really, when you add complex numbers, it's really no different than when you're adding regular numbers or subtracting. It's really the exact same thing. You follow the same procedure, and as I kind of shown here, but I guess it would be best if I just give some more concrete examples to really drive the point home. So let's say, let me just erase the proof, the little basic proofs here, and I'll write something like, let's say z1 is equal to 2 plus 3i. Let's say z2 is equal to 7 minus, I guess, 6i. And what if we wanted to find something like this? What if we wanted to find z1 plus z2? And that's just, of course, going to be as straightforward as you think. You add up the real parts. So let me just even write that out. So I can just say 2 plus 3i plus 7 minus 6i. And just add them like you would, add them how you would with real numbers. So you have 2 plus 7, which is 9, and then you have 3i minus 6i, so this should be minus 3i, and that's the answer to that. Now, what if I want to do something like, let's say I want to do z1 bar minus z star 2. Now, what is the star? The star also means complex conjugate. You can actually write the z bar is exactly the same thing as the star. There's two alternative notations. So basically, it's like, I guess I'll just write it over here. So z bar is equal to z star. So that's in the same way that f prime of x is just equal to d dx, with respect to x. Oh yeah, with respect to x. There's two alternative notations of writing the exact same thing. So what if I want to do z complex conjugate of the first complex number minus the complex conjugate of the second one? So I can do, so let's just write the whole thing out. 2 plus 3i minus, what did I say? What I said was 7 minus 6i. Now remember, we have to take the complex conjugate. So that means that for the first one, we're going to get 2 minus 3i. I'm going to keep everything in parentheses for now. And the second one, we're going to get 7 plus 6i. Just basically, whenever you take the conjugate, only the imaginary part changes. The real part stays the same. And so for here, we're just going to get 2 minus 7, which is negative 5. And then we're going to have negative 3i plus 6i, which is going to be plus 3i. and that is the answer to that. So basically, this is kind of an overview of what addition and subtraction is all about. And next video, I'll be talking about multiplication and division. And after that, I'll get into polar coordinates, and from there, it's going to get really complicated really fast. So I hope you guys enjoy, and I'll see you guys in the next video.